Okay guys, so here's our second example for law of cosines. This one is a little bit different and has a little bit of a different feel to it, so I just wanted to do this before I gave you a few to practice. So if you can see here, now I'm giving, you have a triangle and you have all three sides and you have no angles. So this is another case where we have to use law of cosines, and you're just going to have a different a different setup. You're gonna have to solve for the angle. So all of your little lowercase letters are going to be filled in with numbers. Here's the other little red notes that I want to make for you. Last time when we had one angle and two sides, we went through, used law of cosines to find the angle, find the third side that went with the angle that we had. And then I gave you a little red note that said you have to find the smaller angle first. Now that we are trying to find an angle with all of the sides, we need to find the largest angle first. And so those are the two things you're going to have to kind of keep straight. In this scenario, you have to find the largest angle first. Okay, and that's important because, again, you could get a wrong answer if you don't do it this way. All right, so when I have 9.47, 15.9, and 21.1, the largest angle is going to be angle C because its side is also the largest. So I'm going to use that third formula, and I'm going to start with C squared equals A squared plus B squared minus 2AB cosine C. Okay, and so C squared is going to be this 21.1 equals 9.47 squared plus 15.9 squared minus 2, oh boy, 9.47, 15.9, and then times, and that's where your cosine C is going to be, okay? So, again, a lot of calculator work. Please be careful how you do this. I typically will kind of move things around. You would need to solve for this cosine of C. You would need to subtract these two values, then divide by this one. So cosine of C is going to be this really kind of complicated fraction. I'm going to have 21.1 squared minus 9.47 squared minus 15.9 squared divided by, and then remember this is negative 2 times 9.47 times 15.9, okay? Use enough parentheses when you plug that into your calculator. And also remember, that's not the final answer. That's what cosine of C is equal to. We're going to need to use an inverse cosine. When you plug this large fraction into your calculator, you should get this number. So please make sure you pause and try this so you can check yourself. Now I'm going to put, I do not want to round this, right? I want to keep this exact for when I take the inverse cosine of it. So this is what my calculator said, all those digits. And then when I take the inverse cosine of that, I get, hold on, because I have negative 0.34109.402. Oops. I get, now that I have my calculator, I can do this. I get C is equal to 109.944 degrees. Okay, so there is my obtuse angle in my triangle. Remember, you can only have one obtuse angle. So we solve for the biggest angle, and we got this. Just like the last example, now that I have the bigger angle, now I can go through and use my law of sines because that's a lot easier, okay? So now, hey Julia, stop. So now I have, I'm going to solve for the smaller angle. So let's just go ahead and get in good practice of doing that, because in this case, because we already found the larger one, it doesn't really matter, but I'm going to go ahead and do sine of A over 9.47 equals sine of 109.944 over my C value, which is 21.1. And if I use my calculator for that, I get 9.47 sine of 109.944. I'm going to divide that by 21.1. And then I need to take the inverse sine of that number. And I get an A value, an angle value for A of 24.954 degrees. Now that I have two of my angles, I just use subtraction. So 180 minus that number minus 109.944, and I get 45.102. So angle B will be 45.102 degrees. All right, so there is your second example for your law of cosines. And if you have any questions about that, send me a message and we'll talk. All right, we'll see you later.